Alright, so in this video we're going to dig deeper into circles and talk about tangent lines. So a tangent line is a line that intersects a circle in exactly blank point. So looking at this line, how many times does it hit the circle? Once. So it's going to hit it at one point. Okay, the point of tangency is the point where the circle and the blank line intersect. That'd be tangent line. Okay, so this point right here, C would be the point of tangency, where that tangent line is going to hit the circle. Okay, something cool happens when tangent lines hit a circle. So if a tangent line, or if a line is tangent to a circle, then the line is also perpendicular. Okay, so remember perpendicular is a 90-degree angle. So we're going to be dealing with 90-degree angles being formed when a line hits a circle. Okay, so it's going to be perpendicular to the radius. So notice I've got this line, it's tangent, it hit a point once. What that means is I have a right angle right there. Okay, so we're going to be dealing with right angles and shapes and all kinds of cool things. So let's look at this first example. I want you to solve for x. And so what they'll have to tell you is they'll say lines that appear to be tangent are. Because this line looks like it hits it once, and so we're going to assume it does. So right here I'd have a 90-degree angle. Same thing over here, this line is tangent 90-degree angle. So then you're going to use your knowledge of a kite to solve for x. Okay? So you could say 35 plus 90 plus 90 plus x equals 360, because it's a quadrilateral, it's got four sides. Okay? Or you could do 360 minus all of your angles. Okay? So you would get 145. So x is 145 degrees. So why don't you try this bottom right one? Solve for x, press pause, and we'll go over the answer. Alright, so for the bottom right one, you had a tangent line right here, so point of tangency, right angle. So you've got a triangle, which equals 180, so I subtracted 180 from 90 and 36 to get 54 degrees. Okay, so not that bad for solving for a variable when you've got a tangent line. Now they obviously get a little bit harder. Okay, so it says, what is the radius? So I'm looking for x, and I've got two x's because I've got two radii coming from this triangle. So I have a right triangle, and I know all the sides, and I don't know any angles. So that means I'm going to be using the Pythagorean theorem, which you remember is a squared plus b squared equals c squared. So again, a and b are your legs of your triangle. So this could be a or b. I'm going to call it a. This would be my b. And this whole thing right here is my hypotenuse, is my c. So notice I'm going to have to add 7 and x together to get my c. So x plus 7 would be my c value, a would be 12, and b would be x. So if I plug it into that Pythagorean theorem, I would have 12 squared plus x squared equals x plus 7, all of that squared. Okay? So we're going to have to go back to algebra in quadratics and solving quadratics to figure out how to solve for x. So, first off, squared. Squared means you're going to write something twice and you're going to multiply. So I'm going to actually do that down here. So it says, hey, write x plus 7 twice and then multiply. So remember, x times x is x squared, and x times 7 is 7x. Okay, I've distributed that x to all my right terms. And now I'm going to do 7 times x to get 7x, 7 times 7 to get a 49. Last step is to combine like terms. I've got two 7x's, so that would give me a 14x plus 49, bring down x squared. Okay, so we're going to have to go back to multiplying. So I'm going to replace this with up here. So this term now becomes x squared plus 14x plus 49. Now, after that, it's not so bad. So I'm going to simplify 12 squared to get 144, because 12 times 12 is 144, and bring down plus your x squared. Now this looks hard, but it's not. So first off, I'm going to subtract x squared on both sides, and guess what? They cancel. So now my problem is 144 equals 14x plus 49. And now it's a two-step problem where I'm not going to have to square root anything. So I'm going to subtract 49 on both sides. 144 minus 49 is going to be 95. Divide by 14. So my x is going to be a funky decimal, but I'm going to round it to the nearest tenth. So 6.8. Okay? So that is the radius of this circle. Okay? There and there. Cool. So again, the trickiest part is remembering how to multiply a binomial. And then once you get that, it's not so bad. All right. Why don't you try this one on your own? Press pause. You're going to be looking for the radius, and remember, round to the nearest tenth. So for this one, I had 16 squared plus x squared, again, order didn't matter, equals x plus 9 squared. Down here I multiplied by binomials, and I had x squared plus 9x plus 9x plus 81. So if you can figure out a shortcut, all you're doing is doubling whatever you multiply x times 9. So doubling that would be 18x, and that would be in the middle. And then 9 times 9 will get you this last number over there, if you can do that shortcut. You're going to subtract x squared, which you're going to cancel out. So it becomes a two-step problem where you subtract 81 and divide by 18. And you should get 9.7 for your radius. Okay, so not that bad. All right, let's look at a real-world problem. I'm going to cover this up right now. All right, so the CN Tower in Toronto, Canada has an observation deck that's 0.447 kilometers above the ground level. How far is it from the observation deck to the horizon if Earth's radius is about 6,400 kilometers? So here's a picture really quick to help us out, because it's kind of hard to visualize. So you've got Earth's core. Here's Earth. It's round. You've got the center, and then you've got how far below it is to the middle of the Earth for each of those. Okay. You've got some observation deck that is above the ground, and you're going to be looking down, and you can only see until this point. You're not going to be able to see what's on the other side of the Earth due to your eyesight. So it's asking how far is it from the tower to this horizon. Okay. So let me label. All right. So the Earth's diameter is 6,400. So 6,400 here as well. I know I've got a 90-degree angle because of that tangent line. And I'm looking for this distance because I want to know how far it is from the tower to the horizon. And I know how far or how tall that building is. So 0.447. Okay. So I have a triangle. Okay. I don't know any angles besides that 90. So I'm going to be using the Pythagorean theorem to look for this side right here. So my whole hypotenuse, I'm going to have to add those together. I picked a great time to make a video during the announcements in the afternoon. Okay, so I'm going to have to add those two together to get 6,400.447. So now I can say my a squared plus my b squared, because those are the legs of my triangle. Oh my goodness.
Sierra Bear Howard, please come to main office. Sierra Bear Howard.
Okay, a squared plus b squared equals c squared. And then I'm going to solve for x. Okay, so that is a really big number, so I'm going to actually do this step in 1, and I'm going to subtract 6,400 squared from each side. So you can do that. If you want, you can just type in this big number into your calculator, and you should get 5,721.7999809. Okay? To get x, I'm going to square root to get rid of that squared. So when you type that into the calculator, you should get 75.64, and we are in kilometers. So basically, you can see that far out before you can't see anymore past the Earth, which is pretty cool. Okay. All right. Sorry for all those interruptions, but moving on, we're going to learn one more theorem. So the next theorem, if two tangent segments to a circle share a common endpoint, then the two segments are congruent. Okay, so I have a tangent line here, I have a tangent line here, and if they meet at the same point, I know this is the same as this. And it's kind of like a little birthday hat on top of a person. Okay, so that is one rule. Two other rules. You have a triangle inscribed in a circle. So again, inscribed means written on the inside. You can also look at this as a circle circumscribed about the triangle. So circumscribed means outside, kind of like circumference. So this circle is on the outside of the triangle. So again, you can look at this as the circle is inscribed of a triangle. You've got a circle written on the inside. Or you could look at this as I have a triangle on the outside, so I have a triangle circumscribed about of a circle. So here's an example. I have a circle inscribed in a triangle. So what happens is you have two tangent lines that meet at a point. So this is the same as this. So I know that this piece is also 39. So same thing here. I've got two tangent lines that meet. So if that is 12, so is this. Again, two tangent lines that meet. So if that side is 19, then this side is 19. Okay, so it wants me to find the perimeter of each polygon. So now I just have to add up all my sides. Okay, so I would say 12 plus 39 plus 39 plus 19 plus 19 plus 12 to get 140. So add them all up. Okay, so let me know if you have any questions about finding the perimeter. Otherwise, why don't you go ahead and try this one. Press pause and we'll go over it. When you double the 9s, double the 15s, and double the 22s, you should have gotten 92 for the perimeter of this second shape. Okay? Alright, two more problems. Solve for x. So you've got two circles, you've got several tangent lines, and I need to solve for x. So if I have two tangent lines that meet outside of the circle, I know this side is the same as this side, so I'm going to set up an equation to make them congruent. So 2x plus 37 should equal 6x plus 5. Let me subtract 6 on both sides, because I've got variables on both sides. Negative 8x plus 37 equals 5. Subtract 37. Negative 8x is going to equal 32. Negative 32. Divide by negative 8. And x should be a 4. Okay? So again, if you've got two tangent lines that meet outside of a circle, they are going to be congruent. All right. Well, why don't you try this one on your own? It tells you that EC is equal to DE plus AF. Find the perimeter. Press pause. First thing I had to do was find that DE was a 6, so I had to use that here. I also had to find AF, and I got 19. So when I add 6 plus 19, I got 25. So I now know what EC is, and therefore BC. And then you add them all up to get a perimeter of 100. Okay? So that's a brief introduction to tangent lines. Now you can start to practice. Thank you for watching.